Greetings, this is the 9-week review for the first 9 weeks for BC Calculus. I did want to take a minute and just kind of go over the bullet points here. So remember, this review is not all-inclusive, and the test can definitely include things that are not on this review. The test is made up of 10 multiple choice and 10 free response approximately. So that kind of gives you an idea, and it will cover everything from Unit 1 and Unit 2. So make sure that you know how to evaluate limits algebraically, including the case of 0 divided by 0, the case of a number over 0, meaning there's a vertical asymptote, so you'd have to use one-sided limits, and also limits approaching positive or negative infinity, so that's where you're going to be using your horizontal asymptote rules. Be able to tell the difference between evaluating a function and also the limit. Should lead into your definition of continuity there. Continuity of piecewise, so make sure you know your left and rights, things like that. So the rate of change related to a derivative, so if it's asking you for the rate of change or the slope of a tangent line, you should be thinking derivative there. All the derivative rules, including power rule, product, quotient, and chain rule. Don't forget, trig is also, you are expected to know the derivatives of trig functions, how to evaluate E and ln, the equation of tangent lines, vertical and tangent lines, use implicit differentiation, and related rates. So basically, all of those are included, and I was going to do some examples of each of those, and I'm just going to scooch this up. Okay, so first, when asked to evaluate a limit at a number, the first thing you always want to try is by plugging in that number. So when I plug in a -2, I get -2 plus 2 is 0, and when I plug in a -2 into the denominator, right, so -2 plus 2 over -2 squared is 4 plus another 4. So you get 0 divided by 8. So 0 divided by 8 equals 0, and you're done. Okay, remember, it's okay for 0 to be divided by a number. It's not okay to divide a number by 0. So next we have this case. So in this case, if I plugged in a -4, I'd end up with 0 over 0. Okay, so this is where we kind of said, all right, well, that makes me sad, so I need to do something else. Well, in this case, I'm going to factor, so I'm going to say that this is equivalent to the limit as x approaches -4, and the numerator I just leave alone, but the denominator can be factored into x plus 4 and x minus 4. Okay, so let me scooch that over, sorry. Here, you can cancel. So this is going to be mathematically equivalent to if the limit as x approaches -4 of 1 over x minus 4. And now you're going to just plug in again. So if you plug in this time, now I can drop the limit. Remember, you don't drop the limit until you actually plug in. So you have -4 minus 4. So your answer is going to be -1/8. Okay. And we'll go back over here. Here, again, if you plug in 0, right, you're going to have 3 minus 3, which is 0, over 0. So that's a problem. So in the case of 0 divided by 0, you're looking for opportunities to factor, anything like that. So I am going to multiply by the conjugate. So the conjugate of this minus this thing minus 3 is going to be that thing plus 3. And again, I need to turn it into that undercover 1. So I multiply by that on the top and the bottom. So that's going to be equivalent to the limit, and I'm going to try to write as far to the left as possible, as x approaches 0. So when you multiply by the conjugate here, you're almost doing a FOIL problem in this numerator. So this times this, well, that's going to be that thing squared. Well, squares and square roots are going to drop out. So you're just left with x minus 9. Here I'm going to end up with a positive 3 square root of 9 minus x. And then when I did this, that would end up with a -3 square root of 9 minus x. So those are going to cancel each other out. Again, that's the beauty of multiplying by the conjugate. And when I multiply this times this, I get a -9 over, I would just recopy that. So it'll be this, and I'm multiplying it by that whole thing, plus 3 there. Okay, so this 9 and this -9 are going to cancel each other out. And then also this x would then be able to cancel out here, leaving just a -1 in the numerator. So this is going to be, again, I didn't plug in x equals 0 yet, so I cannot drop the limit until I plug in x equals 0. So I'm basically left with negative 1 over the square root of 9 minus x plus 3. Well, now I'm going to plug in x equals 0, so that leaves me with negative 1 over, let's see, if I plug in a 0 there, the square root of 9 is 3, plus 3 gives me a 6. So my final answer is negative 1/6. Okay? Okay, in part E, a limit approaching infinity. So basically that's saying what's happening as you're looking at this graph. If you're going way, way, way to the far right-hand side, that's asking you if there's a horizontal asymptote. So you need to remember your horizontal asymptote rules. And we say, all right, it's balanced here. So the degree of the numerator and the degree of the denominator are the same, meaning the equation is balanced. So when that's the case, there is a horizontal asymptote. And to find it, you take the leading coefficients. So here, this has a horizontal asymptote at 3 over 4, and you're done. All right. Very similarly here, you're trying to see if there's a horizontal asymptote. We're comparing the degrees. The degree of the numerator is 1 because the exponent on x is just a 1. And the exponent on the denominator is a squared. So I say that this is bottom heavy. Whenever you're doing something there and it's bottom heavy, you're going to have a horizontal asymptote at y equals 0. So this one is just going to be 0. And I'll just make a note. It is bottom heavy, meaning the degree is larger in the denominator. Okay, so here, this is one. Again, our first go-to is always just to try to plug in. So if I plug in a 4, okay, 4 squared is 16. So here I can plug in and I would get 8 over 32. And you can reduce that if you'd like. Divide both of those by 8. So I would get 1/4. And that's done. Okay, moving on to number 2. Number 2, it gives you a piecewise, and we're trying to determine if there is a limit. So when you're taking the limit with a piecewise, you need to approach it from the left and the right. And basically what that means is that you need to look at, plugging it into the top here and the bottom there and seeing if you get the same thing. Okay, so I'm going to take a right and a left-hand limit, and that will tell me if my right-hand limit and if my left and my right-hand limits are the same, then the limit would exist. So I kind of break it up. So first I'm going to take the limit as x approaches 2 from the left. So that would mean, x less than 2, that would be from the left. So I'm going to plug 2 into this top equation. So when you plug in a 2 to that top equation, 2 times 3 is negative 6. Okay, the limit, sorry, I should have g of x there, equals, so I'm going to have negative 6 plus 5. Well, negative 6 plus 5 is a negative 1, so just kind of hold on to that. Now I need to take the limit of g of x as x approaches 2 from the right. So now I plug in 2 to this bottom part, and let's see, what does that give me? 2 times 3 is negative 6 again, and minus 2 over 4. So negative 8 over 4 is negative 2. So negative 1 and negative 2 are not the same number, so you can conclude that the limit does not exist. So therefore, the limit as x approaches 2 of g of x does not exist. And you're done there. And that's the first page. All right, so we'll just flip. For what value of c is f of x continuous? Okay. So we want to find the constant that makes it continuous. So to be continuous, you have to evaluate, basically that's saying that f of pi over 4 exists, that the limit at pi over 4 of f of x exists, and that those two things have to be the same. Okay, so that's kind of our goal here. So what I would do is take it from the left and the right. It's going to exist because this one does have an or equal to sign. So when I take my limit from the left, so I take the limit as x approaches pi over 4 from the left of f of x. And let's see what that's going to be. Well, that means I'm plugging into this one. So if I plug into that one, it's going to be c times the sine. Well, let's see. If I plug in pi over 4 and I multiply it by 2, that's 2 pi over 4, which reduces to just pi over 2. Okay, so I've got that. And let's see. I could do a little bit better because the sine of pi over 2 is 1. So that's c times 1, right, which is just c. So I've got my left-hand limit. Now I'm going to try to find the limit as x approaches pi over 4 from the right, again of f of x. And so now I'm plugging into there, so it's just the cosine of pi over 4. Okay. So cosine of pi over 4 from your unit circle is going to be positive radical 2 over 2. Okay. So all I need is for c, for this and this, to be the same. Well, that's easy. I didn't even need to solve. So basically, if c equals this, then the function is continuous. Okay, so we just set those two things equal to each other. Now, sometimes you may have to solve, right? Say up here, I ended up with, blah, blah, blah equals 2c. Then I would set 2c equal to whatever you get here, and then you'd solve. But here, it was just nice. So that's perfect. You can have I answered the question. It says for what value of c is it continuous? So for c equal to square root of 2 over 2. Okay. All right, so now we are finding derivatives. So find the derivative of the following. This is going to be straight power rule. This, we would rewrite it and use chain rule. You're going to use quotient rule here. And then this is a trig function there. So let's see, power rule. I would say y prime equals 3 times negative 4 is negative 12x squared plus 6x minus 5. So you've got that there. And for this one, I would just rewrite it. This is equivalent to x squared minus x raised to the 1/2 power, and then it becomes a chain rule. Okay, so f prime of x, this comes out front. Copy the variable. Decrease the exponent by 1, so that goes to the negative 1/2. And now I multiply it by the derivative of the inside, so that's 2x minus 1. Okay, and that would be your safe stop. However, if it was multiple choice, it may be written, this is a negative exponent, so that's going to the denominator, and it's power over root, so we're going to take the square root of this thing in the denominator. Also in the denominator is this 2, and this part would be the numerator. So you may see it written like this. Okay, and I would definitely just kind of leave it at this first step if you can. Okay, so over here we have a quotient rule. So you have y prime. You have bottom times the derivative of the top minus the top times the derivative of the bottom, or low d high minus high d low, all over low squared. And so this is your safe stop. If you continued simplifying that, and again, I would not recommend simplifying it unless it specifically asked you to, okay, because you do not want to risk, oops, that's a negative. You don't want to risk an algebra error. And then, let's see, yeah, and I would still leave that denominator. I wouldn't bother foiling that out. Okay, but if you were insisting on going there, you could go to like 42, because those 9x's are going to cancel. And that would be 9. If you did FOIL this out, I guess you'd end up with this, but I would not recommend it. Plus 36, okay? So any of these would be acceptable answers. All right, and this last one. So what you want to do here is use chain rule, okay? So we have, let's see, the derivative of sine is cos. So I would say f prime here is going to be cosine, and you just recopy it, right? Then times the derivative there would be a 2x. And there's your safe stop. Again, they may rewrite it like this, but you're good there. Okay, so that is 1 through 4. The next derivatives are a little bit more complicated, so stay tuned.